My name's Mary Ondrechen. I'm a professor of chemistry and chemical biology, and I run a research group in functional genomics and computational chemical biology, and I teach both graduates and undergraduates here. I started off interested in science as a child. My parents cultivated that. My father taught me about the stars and astronomy, and my mother took me to a class at the Science Museum to learn about different kinds of rocks and different kinds of fish. It was a very exciting experience. I was a very small child, and that got me hooked on science. I went to a small liberal arts college, so the research offerings at that kind of school are not quite the same as you'd get at a research institution like Northeastern, but one summer I did synthetic organic chemistry, and then another summer I did radiochemistry, and there were some workers who might have been exposed to mercury, so I analyzed hair and urine samples for mercury, and I did some radiochemical studies as well. I studied quantum theory, paper and pencil quantum theory. I was very interested in math, and I derived equations to explain electron transfer rates, to explain vibrational relaxation. It was very mathematical. Oh yes, yes. When the human genome was sequenced, this happened about 6 or 7 years ago. I decided to make the switch into biomedical problems because I thought that the human genome was opening up opportunities that were just too good to pass up. So now I'm doing exclusively biomedical problems. Oh, the most rewarding aspect of research is the thrill of discovery, the thrill of finding new things, and also working with students. It's so nice to see these minds developing and being a part of the discovery process. One example of a project that an undergraduate has been working on is the study of allosteric enzymes. We have a method to locate interaction sites of proteins, and one undergraduate asked what happens if you apply the method to allosteric enzymes, because they have two interaction sites. They have one that is the catalytic site and another that is the allosteric or ligand binding site. And she worked on showing that the method finds both. And there's some very interesting results about how allosteric enzymes work. What do I like to do in my spare time? Well, one of my hobbies is actually environmental advocacy. I have worked as a volunteer for environmental cleanup problems, cleanup of toxic and radioactive waste. I've helped to advocate with Indian tribes to clean up federal sites near Indian land. And so that is one of probably my biggest hobby, my biggest pastime. Oh, some of the undergraduates who've worked with me have published papers with me. I had one undergraduate that got some very significant results with the KEX2 protein. The KEX2 protein was a structure that was sought after for a very long time because it's a target for therapies for cancer metastasis. And the KEX2 structure was very difficult to solve. It was solved by friends of ours at Brandeis, and this student did a computational analysis, a very careful computational analysis of KEX2, and specifically found what are the specificity determinants in KEX2. It's a protease, but it's a highly specific protease. And she was able to uncover exactly what makes it specific. So that provides information for design of therapies. It's very significant work, and she co-authored the publication with us. We've had several undergraduates over the years co-authored several papers with us. Try different things and also try to bring a problem to completion. Work hard and try to spend long enough on the project so that you can publish something and bring it to completion. I think that's an excellent experience to bring to graduate school if you've already published something. That's an excellent aspect of the resume if you're applying for fellowships or perhaps even for industrial career, to show that you're actually able to do original work and bring it to completion if you're applying for a job in industry. That's a good thing to have on your resume.